This is a video from the Exam 4 review. Let's take a look at problem 27. It says to verify that the integral from 0 to 1 of x squared cosine x dx is less than or equal to 1/3. Now, here's what we know. Cosine x is less than or equal to 1. We also know x squared is greater than or equal to 0. So if I multiply both sides by x squared, I get x squared cosine x is less than or equal to x squared. The integral from 0 to 1 of x squared cosine x dx must also be less than or equal to the integral from 0 to 1 of x squared dx. Now, let's take a look at the integral from 0 to 1 of x squared dx. This is 1/3 x cubed evaluated from 0 to 1, which is 1/3 of 1 cubed minus 1/3 of 0 cubed, which is equal to 1/3. Therefore, the integral from 0 to 1 of x squared cosine x dx is less than or equal to 1/3. And that's how we do problem number 27. Let's take a look at problem 28. On problem 28, we want to verify the integral from 0 to 1 of e to the x cosine x dx is less than or equal to e minus 1. Well, what's going on with that? I'm going to start off the same way and say cosine x is less than or equal to 1. E to the x is always positive, right? So therefore, e to the x cosine x is less than or equal to e to the x. The integral from 0 to 1 of e to the x cosine x dx must then be less than or equal to the integral from 0 to 1 of e to the x dx. So let's take a look at the integral from 0 to 1 of e to the x dx. So this is equal to e to the x evaluated from 0 to 1. If I replace x with 1, I get e to the first. If I replace x with 0, I get e to the 0, and I have to subtract. And so the integral from 0 to 1 of e to the x dx is then e minus 1. And so that implies the integral from 0 to 1 of e to the x cosine x dx must be bounded above by e minus 1. And that's how you do problem number 28. If you take a look at problem number 29, 29 is interesting. So on problem 29, you get the integral from 0 to 3 of the absolute value of x squared minus 4 dx. Okay, what's going on with this one? Well, what I want to do is I want to graph y equals x squared minus 4 first. Okay? And I want to see what that looks like. Now, what that looks like is the following. So we're going to go down 4. And so I start off with 0, negative 4. I go over 1, and then I go down 3. I go over 2 and I stay. And then at 3, you get 5. So it's something like this. Right? But when you're dealing with the absolute value of x squared minus 4, it's a little tiny bit different, right? So if you have y equals the absolute value of x squared minus 4, what's going on there? Here's x, here's y. This time at 0, we're at 4. Okay? When you go to 1, you're at 3. When you go to 2, you're still at 0. So it's coming down like this, right? And then at 3, you go back up to 5. And so it's going to come up. So essentially, we need to get this area, right, up to 2. And then from 2 up to 3, we need to calculate this area. So we need to break up this integral at x equal 2. But remember, when you take the absolute value, you always have to get something non-negative back. That's the tricky part about absolute value. So, okay, so we're going to come around here, and we're going to start with the integral from 0 to 3 of the absolute value of x squared minus 4 dx. So I'm going to break this up at 2. So if you go from 0 to 2, right? If I plug in 1, notice how we get a negative number back. But remember, when you take the absolute value of a negative number, you got to get something positive back. And so I claim this is going to be 4 minus x squared dx. Now, let me see if I could draw a number line for you guys. So here's 0, here's 3. At x equal 2, it's 0, right? The y value is 0. Between 0 and 2, like if I test x equal 1, and I plug 1 in for x, we get a negative number. We can't have that. We have to have a positive number because of these absolute value bars. So I have to take the opposite of x squared minus 4. The opposite of x squared minus 4 is 4 minus x squared. I just changed the sign of each of the terms. But if I go from 2 to 3, I can strip away those absolute value bars and just write x squared minus 4. That's how this works. Now, here I get 4x minus 1/3 x cubed evaluated from 0 to 2. That's the first integral. And then the second integral will be 1/3 x cubed minus 4x evaluated from 2 to 3. Pop 2 in for x. We get 8 minus 8/3. If I replace x with 0, it's just 0. So we took care of the first one. Put 3 in for x. We get 1/3 of 3 cubed minus 4 times 3. Put 2 in for x. We get 1/3 of 2 cubed minus 4 times 2. That's a times, by the way. Now, 8 can be written as 24 thirds. And I subtract 8 thirds. I'm going to go plus. And then I get 1/3 of 3 cubed is 9. And then I'm going to go minus 12. So I go 9 minus 12 for the first one. And for the second one, I get 8 thirds minus 8. So we get 16 thirds plus -3 minus -16 thirds. So -3 can be written as -9 thirds. So this is 16 thirds plus -9 thirds plus 16 thirds. So the correct answer here is 23 thirds. And that's a good stopping point for this video. And this is from the Exam 4 review. And we did 27, 28, and 29. Thank you.